This video will demonstrate how to use function notation. Like this little meme says, function notation is just a fancy way of writing why. So why do we use function notation? Well, it allows us to be a little bit more flexible in what we do with our functions, and that really helps us as we get to the calculus. So, as I said, function notation is a fancy way of writing y. In fact, often functions are written as y equals, and this part here is called f of x. That's how we say it, f of x. It is not f times x. I know every other time in algebra you've seen a number or a pronumeral or a variable sitting outside a bracket with no sign between them. That usually means times. Not in this case. This is a special instance where the f outside the brackets means specifically function of x, f of x. So the output of the function is y, the name of the function is f, and that doesn't have to be f, as I'll explain later, and the input, the thing that you're putting into the function, is x. So let's look at a simple function. This first initial function that I'm defining, and the function usually gets defined first, is f of x, and excuse my weird looking x, I couldn't find one that looked the way I wanted it to look, is 3 times x plus 4. Now ordinarily we wouldn't put that times sign in there, but I wanted to specify the difference between the times and the x. So we're saying for this particular function at this time, in order to get the value of the function, or y, we need to multiply by whatever the x is, whatever the input to the function is, and then we need to add 4. Multiply whatever the input is by 3 and then add 4. So this allows us now to say, well, f of 5 means 3 times 5 plus 4. So I've put a 5 in there inside the function, and it has just replaced the 5 where the x was. And 3 times 5 plus 4 is 19. So the value of the function when x is 5 is 19. Now I could have easily have said, well, y is equal to 3x plus 4 when x is equal to 5, y is equal to 19, and you would have understood that, but as I said, this is going to be really handy for you as you go into the calculus. So f of 3.5, just another example, 3.5 is now being stuck in there as the input, and 3.5 sits there instead of x in the function. So 3 lots of 3.5 plus 4 is 14.5. I could even put another variable. I could put a smiley face in there if I wanted to. The y in there, and that just becomes a y in here, and that becomes 3y plus 4. Let's look at a more complex function, and in fact a reminder also that functions don't have to be f. Almost always they're called f, but sometimes they're called something else. If you've got a real life example where you're making a function that represents volume, for example, you could call it v of x if you wanted. They could be called anything at all. Here's a more complicated function, g of x. It's only more complicated because it's a quadratic rather than linear. So our input is x, whoops, it's not wiggly this time. Our input is x, and it says for this particular function we're going to square x and then add 1. So g of 7, we're going to square 7 and add 1, which gives us 50. G of 0.1, we're going to square 0.1 and add 1, we get 1.01. Sometimes we can combine functions. We can find functions of functions. So if our g of x was our original function, 3x plus 4, sorry, f of x was 3x plus 4, and our g of x is x squared plus 1, what will g of f of x be? And what will f of g of x be? And I've left out a bracket there. Well spotted. Actually, I've left it out there as well. Bother. So g of f of x means that the input for our function g is the whole of our f function. So we're going to put 3x plus 1 into our g function where we see x. I'll show you what that looks like on the next page. F of g of x means that our whole g function is going to go in to our f function where we see x. So x squared plus 1 is going to go in there instead of x. Let's have a look at what that looks like. So g of f of x is not x squared plus 1, but 3x plus 4 squared plus 1. And 3x plus 4, if you're very careful, expands to 9x squared plus 24x plus 16. Actually, I've saved myself some time. Add the extra 1 on, you get 17. F of g of x means put the whole of g of x in where we see x there. So it becomes 3 lots of x squared plus 1 plus 4. Expanding out, 3x squared, 3 times 1 is 3, plus 4 is 7. So you will be absolutely using this sort of thing when you get to the calculus. Thanks for watching.